This is Note-Taking Guide 8.1 for Mathematical Decision Making for Life. Today we're going to start a unit about patterns and logic. So we're just going to run through this note-taking guide and get you started on your homework. This first problem right here says, describe a visual pattern. So sketch the next figure in the pattern. So we're noticing here, let's look at the pattern. Circle, circle, circle. So we know we're going to stick with a circle here. So let's draw our circle. It was cut into fours. It was cut into fours. It was cut into fours. So we know our circle is going to be cut into fours. Then we're just going to follow the circle around. It goes from here to here, which means it went around once this direction. And then it goes from here to here, which means it went around once the same direction, which means on ours, we're going to go around once that same direction. So we know that our circle has to be right here inside that spot. All right, let's look at the next problem. Sketch the fourth figure in the pattern. So let's just take a look at our pattern. We start here with a square that's completely shaded in. Then we go to a square that's cut into half, and only half of that is shaded in. So then if we're just looking at this, we had our square. We cut it in half. And then if you notice, we took that half and we cut it in half again, and then we shaded what was left of that. So when we're drawing our pattern on our square, we're going to start with our square. It would have been cut in half from this one. It would have been cut in half this way from that one. Then I'm going to take one of the squares that was the square that was shaded, and I'm going to cut it in half again, and I'm going to color in part of the square there. So if I were going to just look at this without me having done all of those lines in it, I would just have a little piece just like that for my answer. All right, let's take a look at the next question. Describe the pattern and the numbers 2, 8, 32, 128, and then write the next three numbers in the pattern. So what I'm really doing here is I have to ask myself, what did I do to get from the number 2 to the number 8? What did I do to get from the number 8 to the number 32? And I can see that that's multiplying by 4. So 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. So I found my pattern, or how I describe the pattern would be multiplying by 4. And then it says write the next three numbers in the pattern. So how do I get the next number in the pattern? I would take 128 and I would times it by 4. I would get that answer and times it by 4, and then get that answer and times it by 4. That will give me my next three numbers in my pattern. So let's grab our calculators out and do that real fast. All right, so 128 times 4 on our calculator is 512. So then we're going to do 512 times 4. Punch that in your calculator, and you get 2,048. So then we're going to do 2,048 times 4 on our calculators, and when we do that, we get 8,192 from my answers for my next three numbers in that same pattern. All right, let's go to the next problem. What is the next number in the pattern? So first of all, we have to find the pattern. What do I do to get from -3 to -1? What do I do to get from -1 to -3? And then what do I do to get from -3 to -9? All right, so I'm noticing when I'm looking at this that there's a problem on this problem. So in order to fix this on the note-taking guide on the video today, let's just cross off that first number there, and then let's look at the pattern on the rest of the numbers. So back to what I was saying before, after you cross off that first number, we're going to just pretend like that's a typo. When it's not there, it is a typo. So what do I do to get from -1 to -3? What do I get from -3 to -9? We times by 3. Negative 1 times 3 is negative 3. Negative 3 times 3 is negative 9. So to find the next number in the pattern, I'm going to take negative 9 and times it by 3, and I'm going to get negative 27. So again, you guys, that was a typo on here. Just cross off that first number. I'll have that fixed hopefully before it's actually on the printed copy that you have. But just look at those last 3 numbers here on this page that I have. All right, this next part says, let's make and test a conjecture. Well, what is a conjecture? A conjecture is an unproven statement that is based on observations. You use inductive reasoning when you find a pattern in specific cases, and then you write conjecture for the general rule. So make and test a conjecture about the product of any 2 odd integers. Okay, so product means multiply. So we want to multiply 2 odd integers together. Now, I don't even want you to think about this. Let's just think of a rule and see whether or not we're correct, because that's what a conjecture is finding a rule that's correct or not correct. So let's say we multiply 2 odd integers together. And I'm just going to say because we're multiplying 2 odd, I'm just going to guess that if we multiply 2 odds together that we end up with an odd number. So if we multiply 2 odd integers together, we end up with an odd number. Now, you guys, I don't know if that's correct or not. This was just a guess of something. You could have guessed something like if I multiply 2 odd integers together, they end up to be even. If I multiply 2 odd integers together, they always are positive. I mean, you could really come up with any conjecture. It's really a guess of what you think is going to happen. So to prove that conjecture, we're going to pick some numbers and test our theory. So let's test our theory by picking some odd integers to multiply together. So let's just pick some and try. So let's go like 3 times 5. 3 times 5 are both odd integers. When I multiply that, I get 15. So far, my conjecture of multiplying 2 odd integers will end up with an odd number. That worked for that example. But let's try another one and let's see what happens. So let's try 7 times 9. 7 times 9 is 63. So again, we ended up with an odd integer. So that worked. My guess on my conjecture worked. So, and let's just try another one to say, let's go like negative 1 times negative 9. And when I do that, I still get positive 9, which is still an odd integer. So my conjecture of when I multiply 2 odd integers together, we end up with an odd number. That actually is true. We proved that that conjecture is true. So again, what a conjecture is just a statement that you're trying to use to prove something. It's an unproven statement. All right, next example. Make and test a conjecture about the product of an odd integer and an even integer. So this time we're multiplying an odd integer and an even integer together. So we're just going to write our conjecture. So we're going to say if we multiply an odd and an even integer together, what do we think is going to happen? I'm just going to say then we get an, what do you think? Is it going to be odd or even? Just make a guess. I'm going to go with even. Then we get an even integer. Okay, so that's my guess of what's going to happen. If we multiply an odd and an even integer together, then we get an even integer. So what we're going to do now is we're going to test that conjecture and see whether or not it's correct. So an odd number, maybe like 5, times an even number, maybe like 4, gives me 20, which is an even integer. So that worked that time. Let's try a few more to make sure it works. So an odd number like 3 times an even number like 8 gives me 24, which is again an even number. So let's try it again. Let's say we go negative 7, which is an odd number, times an even number like 10 equals negative 70, which is again an even number. So it looks like my conjecture is true. Sometimes your conjecture is false, and that's okay. If it ends up being false, you can just put that it was a false conjecture. Mine happens to be true, so I'm just going to say that I proved it, that my conjecture is true. Okay. So when we are trying to prove whether or not our conjecture is true or not, sometimes we're looking for what's called a counterexample. So my examples on my last two problems, they always worked because what I picked as my rule was true. But sometimes when our rule is false, we got to find the one example that shows that it's false. That example is called a counterexample. A counterexample is a specific case for which the conjecture is false. So find an example to show that the conjecture is false. The conjecture says all odd numbers are prime. So let's talk about prime numbers. We know that 3 is prime. We know that 5 is prime, 7 is prime, 9 is prime. No, I'm sorry, not 9. 7 is prime. 11 is prime. So is there an odd number that's not prime? And I actually can think about one number that is odd that's not prime. And now remembering that prime means that it's only divisible by the number and it's by the number 1 and itself. So a number that I know to be odd is the number 1. And number 1 is not considered to be prime because 1 times 1 it's itself twice. So I actually found a counterexample that says not all odd numbers are prime because the number 1 is not prime. So that's an example of how to find a counterexample. All right, next question. Suppose Mrs. Clark is a counterexample to the conjecture, all red-headed girls have freckles. So what must be true about Mrs. Clark? Well, if I'm an example of a counterexample on that, meaning all red-headed girls have freckles, I would have proved that to be wrong. So I would know that Mrs. Clark does not have freckles because it was a counterexample, something that proved it false. All right, last example here. It says, find a counterexample to show the conjecture is false. So here's our conjecture. The difference between two positive numbers is always positive. So let's see. Positive like 25 minus a positive number like 10 would be positive like the number 15. That worked. So the difference between two positive numbers is always positive. What if I go 10 minus 12? Would that be positive for my answer? No, 10 minus 12 is actually negative 2, and negative 2 is a negative number. It's not positive. So this would be how I could find a counterexample, an example that proves the statement false. So this is what we're doing today on our homework, you guys. So give it a try. Let me know if you have any questions. Good luck.